Module 18.3, Day 1, Special Right Triangles. Content Standard. Derive and use the trigonometric ratios for special right triangles, 30 degree, 60 degree, 90 degree, and the 45, 45, 90 degree triangle. Language objective. Explain to a partner how to find the sine, cosine, and tangent of 30 degree, 60 degree, and 90 degree triangle and the 45, 45, 90 degree triangle. Applying relationship in special right triangle. The right triangles you explore are sometimes called 45, 45, 90 degree and the 30, 60, 90 degree triangles. In the 45, 45, 90 degree triangle, the hypotenuse is square root of 2 times as long as each leg. So this is the 45, 45, 90 degree right triangle. So the leg is x, and x, the hypotenuse is x times radical 2. And in the 30, 60, 90 degree triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is radical 3 times as long as the shorter leg. You can use these relationships to find side length in each special types of right triangle. So this is the smaller angle, so this is the shorter leg is x, and this is 60, so this is the longer leg, so this is x times radical 3. Then the hypotenuse is always 2 times x. Right, okay, so then let's go through these. Find the unknown side lengths in each right triangle. In the unknown side length in triangle ABC, so we're given that this is a 45, 45, 90 degree right triangle. So this is x, and this is x square root of 2. So we can say that x square root 2 is equal to 10. So to solve for x, that means that x equal to 10. Oops, my mistake. 10 divided by square root 2. But then we cannot have a radical 2 in the denominator, so we need to rationalize it by times everything by square root 2 over square root 2. So this gives us 10 square root of 2, and square root 2 times square root 2 reduced to 2, and 10 over 2 can be reduced to 5, so the answer would be 5 radical 2. So this side is 5 radical 2, and then is 45, 45. This side is also 10, my mistake, 5 radical 2. Okay, let's go on to our next example. In right triangle DEF, angle D is 30 degree, angle E is 60 degree. The shorter leg measure 5 radical 3. Find the remaining sides. So this is a 30, 60, 90 degree right triangle. So this is the shorter leg is x. The hypotenuse is 2 times x, and the longer leg is x. Is x times radical 3. Okay, so then from here it's easier, we can solve for DE. So we say that DE is 2 times x, but x is 5 radical 3, so then this gives us 10 radical 3. And DF is x times radical 3, so x is given as 5 radical 3 times radical 3. So this is 5, and radical 3 times radical 3 is just 3, so the answer is 15. Right. Okay, now it's your turn to number 5 and 6. Find the unknown side lengths in each right triangle. So spend 1 minute to work out these two, and I'll give you the answer in a minute. Right, so for number 5, it's a 30, 60, 90 degree right triangle. So the shorter leg is x, and this is x times radical 3, and this is 2x. So to solve for x, we're given these two, so we can say 2x equal to 4 times radical 3. So x equal to 4 radical 3 over 2, which we do to 2 radical 3. So this is 2 radical 3, and the hypotenuse is LJ equal to x times radical 3, so which gives us 2 radical 3 times radical 3, which gives us 2 times 3 equal to 6. Right, and for number 6, it's a 45, 45, 90. So this is x, and this is x radical 2. So then QR is 2 radical 6. And PQ gives us 2 radical 6 times radical 2. But radical 6 can be written as radical 3 times radical 2 times radical 2. So then 2 times radical 2 is 2. So we have 2 times radical 3. So then, which gives us 4 radical 3. Okay, so trigonometric ratio of special right triangle. You can use the relationships you found in special right triangles to find trigonometric ratio for the angles 45 degree, 30 degree, and 60 degree. For each triangle, find the unknown side lengths and trigonometric ratios for the angles. A 45, 45, 90 degree triangle with the lengths of 1. Step 1, send the lengths of the sides opposite of 45 angles are congruent. They both are 1. The length of the hypotenuse is radical 2 times as long as each leg. So it is 1 times radical 2 or just radical 2. Right, so remember that this is 45, 45, so x, and this is x radical 2. Okay, so we can use that 1, 1, and this is radical 2. Alright, okay, so then use the triangle to find the trigonometric ratio for 45 degree. Write each ratio as a simplified form. So let's go back to our right triangle. Right, so we have this. So this is 45 degree, and this is 45 degree. This is a right angle. This is 1, 1 radical 2. So we said that sines of 45 degree is opposite over hypotenuse. So this gives us 1 over radical 2. But then we cannot have a radical in the denominator. So we need to times everything by radical 2 over radical 2. So this gives us radical 2 over 2, which gives us that. And we know that cosines of 45 degrees is the same as sines of 45 degrees. So this is radical 2 over 2. Right? And for tangent, well, tangent of 45 degrees is opposite over hypotenuse. So I'm sorry, opposite over adjacent. So 1 over 1 is reduced to 1, so it gives us that. Okay, now let's go on to a 30, 60, 90 degree triangle. The hypotenuse is twice as long as the shorter leg. So the length of hypotenuse is 2 times 1, which gives us 2. And the longer leg is square root 3 times as long as the shorter leg. So then the length of the longer leg is radical 3 times 1. So then it's just radical 3. Right? Okay, step 2, complete the triangle. Use the triangle to complete the table. Write each ratio as a simplified form. So for a 30 degrees, so we're observing from this angle, so we have opposite, adjacent, and hypotenuse. So then sines of of 30 degrees is opposite over hypotenuse, so it's 1 over 2, so 1/2. Cosine is adjacent over hypotenuse, so become radical 3 over 2. And tangent is opposite over adjacent, so 1 over radical 3, but we see that cannot have radical 3, so this becomes radical 3 over radical 3. So it becomes radical 3 over 3. Right? And for a 60 degree, we are observing from this angle, so this is your opposite, adjacent, and hypotenuse. So sine is opposite over hypotenuse, radical 3 over 2, and cosine is adjacent over hypotenuse is 1/2, and tangent is opposite or opposite over adjacent, so become radical 3 over 1 or just radical 3. Right? Okay, so then find the unknown sine length and trigonometric ratio for 45 degree angle. So we're given that this is 10, and we need to solve for these two. Right? So we can use tricks. So we say that sines of 45 degree is equal to opposite over hypotenuse. But we know that sines of 45 degree is radical 2 over 2, which gives us x over 10. So then we can use our cross product. So this becomes 10 radical 2 over 2 gives us x, reduced to 5 radical 2 equal to x. Okay, so then here use the figure to the right for problem 1 through 4. Write each trigonometric ratio as a simplified fraction and as a decimal rounded to the nearest hundred. So for number 1, we're looking at angle L. So sine of angle L is opposite over hypotenuse, which gives us 12 over 13. Right, and then we said to use the calculator to reduce that 12 over 13. So it would be 0.9 to the nearest hundred, so 0.92. And cosine of angle L is adjacent over hypotenuse, so we become 5 over 13. This gives us 0.38. And tangent of angle M, so tangent is opposite over adjacent, so 5 over 12. .41, and sine of M is opposite over hypotenuse, so 5 over 13. This gives us 0.38. Okay, and then for number 5, write each trigonometric ratio as a simplified fraction form. Right, so here for this one, we need to go back to our table here and this table. Right? Okay, so then sines of 30 degree is 1/2, and cosines of 30 degree, well, if we go back to our table here, it says cosines of 30 degree is radical 3 over 2. So this becomes radical 3 over 2. And tangent of 45 degree we know is 1. And tangent of 30 degrees, similarly go back to this table here. So we say tangent of 30 degree is radical 3 over 3. And cosines of 45 degree is radical 2 over 2. And tangent of 60 degree is just radical 3. Alright, so that's the end of our notes for 18.3, day 1. Your assignment is number 5 through 12 in your textbook. We have a new HRW, and also we need you to copy down 18.3, day 2 notes.